Hi everyone, welcome to part 2 of the Kwyll tutorial. In this part we're going to continue on from where we left off in part 1, which, if you recall, we had the ability for the player to traverse rooms. We had different room configurations, so you could combine different graphics on each corner and each north, south, east and west entrance exit location to give a variety of rooms and make an interesting map. And we introduced the idea of doors that could be locked and then unlocked to allow you passage through to neighbouring rooms. Now, the way we left it was that the player was able to unlock any door, so all you had to do was bump into the door and the door would open. So what we're going to introduce in this part is the concept of keys and locked doors. So if you remember, there were 4 different door colours: red, green, blue and gold, and we'll introduce keys for the same colours. Each key will unlock the matching door, and we'll add the logic to what we've already got for unlocking doors to make sure that the player has the correct key to be able to unlock the door. And then we'll scatter keys around in the map in a suitable way so that we can test that it's possible to get round, collect keys and unlock previously locked areas. Just to finish up, we'll add a little bit of feedback, and we'll start introducing some concepts around the screen section of Kwyll and instruments. So we'll add some user interface elements to the game so you can see which keys you've collected, and perhaps some feedback in other areas as well, depending on time. So without further ado, let's get into the next part of the tutorial. Okay, so the first thing we're going to need is some graphics for our key. We'll create both a tile and a sprite. We don't need the tile just yet, but we'll need it shortly, so we'll create it at the same time. Both are going to be 8x8, that's adequate for a key. So we'll need to create a new sprite sheet. We'll call it collectibles, I think. Make sure that it's 8x8, and we'll draw exactly the same simple key in there. So now that we've got our sprites, we can create some objects. We'll start with the red key. We'll create an object for each of the keys, each of the coloured keys. We'll set a single sprite, the key sprite that we just created, and we'll set the single colour to red for this one. So that's how we create each key object. I'll rush through the other 3. It's all exactly the same. Green key first, single sprite, and set the colour to green, and then the blue key to blue, and the gold key finally to gold. So now we have our 4 objects. If we go to our room and look at the objects, we've now got these 4 coloured keys. I'll drag one of each into the room because we want to be able to configure each room to have any combination of keys. We can have up to 1 of each. So we'll place them there, but we'll place them off screen, off outside of the room, so they can't be seen to begin with. Then we'll use a similar mechanism to that we used for the corners and the doors to place the keys dynamically for each room. So we're going to need a way of positioning them, and I'm going to use a feature of Kwyll called markers, which are very lightweight objects that have basically just a position, and they can be placed visually, so you can place them on the map in a friendly way and then use them in code to place objects or to move objects to various locations. So you create one by dragging off this pin here in much the same way as you would an object, and drag it into the room. We'll put the first one up here, and this is going to be our off-screen or not available position. This is where the keys will go when they're not visible in that room or they've been collected. And then we're going to need a similar pin for each of the alcove locations, which is why we placed the alcove corners in, so we can visually see where we want to put it. It's worth noting at this time that the tip of the pin that you see is where the top left corner of the sprite will be placed. So you have to be careful when placing the pins to make sure that the sprite, when put there, will be accessible by the player. So if we delete those temporary brushes, we can now see we've got the 5 locations for our keys. So now to place the keys, we go back to our room logic where we were placing corners and doors. We'll need another room entered because this is something that's going to be configured as you enter the room, much like all the other elements of each unique room. For this particular aspect, we need to use the transport to marker node, which transports an object directly to a particular marker. So we're going to need an object reference to move, and for that we'll use the get room object node, and we'll specify the forest room and initially the red key. So this will give us a reference to the red key within the forest room. And then we're going to need to know which marker to move it to. So for that we're going to need 4 more room configuration variables, 1 for each coloured key. And these variables will be set in the map in the same way as the corners and the doors, the exits are, to define which location, if any, that particular key is to be placed within this room. So once we've got those 4 variables defined, we can just drag them in and use them as our marker index, which will index the markers that you saw me place earlier in the room. And you can see in the list markers 0 through 5. So just cut and paste each one and just change the object to the next object and the appropriate configuration variable. We'll do that 2 more times for the blue and the gold key, and that should be all we need in order to place any combination of keys in any combination of alcove location within each room on the map. So if we just finish that off and then go to our map, we can see this in action. So first things first, let's see, you can see we've got these 4 additional variables here, but first things first, in this room here where we have no doors at the moment, I'll put in an alcove corner. I'll put it in the northwest, and then I can place the key in that alcove. So if we have a look, it's going to be key marker 2. So if we go to the variables, the configuration variables for that room, and the red key, we'll put it at marker 2. So now if we move into that secondary room, we can see we've got the key, but unfortunately I placed the wrong corner. So going back to the configuration variables again, what I'll do is I'll change the corner, the northwest corner, back to normal, and the northeast corner instead to an alcove, and that should fix that. So now we can go and look at that room, and we've got a key in an alcove which is accessible to the player. It doesn't do anything at the moment, so you can't collect the key, but that's what we'll look at next. Okay, so now that we've got a means of placing the keys in the room, we're going to need a way of having the player collect them. So there's various different ways we could do this, but the way I'm going to choose for this particular tutorial is to have the player object detect when it hits one of the 4 keys and inform the room via another message, send a message that that particular key has been collected, and let the room take care of what it needs to do from there. So in the player we already have a check for type door detector, which we use to send a message to the room that we've hit a door. So we're going to feed off of that. We've already got an object hit reference for when we've moved the player, and we're going to check if it's not a door detector, check to see if it's a red key to begin with, and if it is, we'll send another message to the room to tell it that the player has hit the key in that particular room. We'll set the ID to 2, so the previous one, as you can see above, is ID 1, which is for open door, and we're going to set P1, our parameter, to 0, 1, 2 or 3 for red, green, blue or gold key. So we just duplicate this very quickly for each one. It's very simple. Green key is parameter type 1, and then blue key will be if it's type blue key, we want it to be parameter type 1. Parameter 1 will be type 2, and then finally duplicate it one more time for the gold key. Connect up the object reference that came back from the collision check, and if it's false, make sure it's in the flow, and change it to gold key, and change it to type 3. So this will pass a message through to the room saying the player has hit a red, green, blue or gold key. So now we're going to need a handler for this message. We had one already for the doors, and we're going to create a similar thing on message. This time it's going to be ID 2 because that's the ID we're sending, and if you remember, P1 is the index of the key type: 0 for red, 1 for green, 2 for blue, and 3 for gold. So what we're going to need to do is we're going to move, for each key type we'll check to see if it's if the index is the key that we're expecting, and we're going to move the key off to the off-screen marker so that it basically hides it. We'll get the room object because we know index 0. If P1 is 0, the player has hit the red key, so we'll get the red key reference for our transporter marker, and we'll set the marker to 0, which, if you remember, was our off-screen marker, which basically means it'll move the key off-screen and invisible. And this is due to the fact that we have no way of hiding objects at the moment, but by the time we get to release 1, that will be in there. But this is a suitable way of doing it for now. And then we set the room variable, or the location variable for the red key, to 0, and this makes sure that when you leave and come back into the room, the red key will remain at marker 0 and off screen because it's already been collected, much like the door logic changed the door variable, the exit variable, to make sure the door remained open. So we're just going to duplicate this for each one, filling in the flow, making sure that we fill in the parameter link, and we'll check for 1, 2 and 3 and move and set the appropriate variable for the other keys. So this should mean that once this is all in place, we have the ability to collect and visually display that the key has been collected in the room for any of the different types of key. So if we go to the map, we should be able to see this in action if we do a quick test in the preview. And before we go, I'll just rename these or add a name to these two handlers now that we've got more than one message handler, so that we know what each flow is for at a glance, so we don't have to look at it and work out what each one is doing. So now if we go into our room 2 where I placed that red key, and we couldn't collect it before, but now we collect it, and if we go out and come back in, it should stay collected. And that's happening by, if I quickly restart to show you the state of this particular red key variable in the room. In this room, it's currently set to 2, which is the location where the key currently is, and as soon as we collect it, it's changed to 0. So when we come back out and come back in again, the initialized code will ensure that key remains collected. So now that we've enabled the player to collect keys, we need to make sure that the doors can only be opened if the player holds the right coloured key. So looking at the room logic for opening the door, if we recall, we moved the code for actually performing the door open into a subgraph. You can see 3 of the 4 here for each type of door, or each side of the door, each side of the room, sorry. So the reason for this was it made it easier when we came back to looking at making sure that the door and key combinations were correct. It was all in one place and we didn't have to duplicate lots of code. So that's what we'll do now. We'll dive into this subgraph and we'll add the code necessary to make sure that we check that the player has the right key. So looking at this, it's very simple at the moment. It just replaces if the type of current tile on, or brush on that side of the room is a door. It just replaces it with an empty brush. So what we're going to need to do is add some additional variables. We're going to add these into the global logic so that both the player and the room can access them very easily. So this is just going to be like a very simplistic inventory type system. So we're just going to list how many of each key type we have. Certainly in the initial implementations of this game there'll only be the potential to have one of each type, but if we have each as a variable, then we can potentially add the ability to collect more than one of each type later if we choose to. So with those in place, back to the player object, when they collect a key, as well as telling the room that the key has been collected so the room can do what it needs to do to remove it from view, the player will set the appropriate global variable to indicate that we have one of the correct types of key. So red key there, set it to 1 for now. We can do an increment, but for now we'll just do 1. Actually that needs to go down here on the red key flow, not on the door detector flow. So that's all that's needed there. So we'll just duplicate that up 4 times for each key type. So we're just going to increment or set the appropriate variable to 1 for each coloured key as we collect it, and that'll be enough information for the door unlock logic to check those variables and see whether we have a key and are actually able to unlock that door. So if we go back to the room, having completed that, we should we now need to add some code in here that checks to see that the player has the right coloured key for the door that's being opened. So we're going to need a way of checking that the player has the right key for the door that's being opened, which is passed in through the door type parameter. So let's give ourselves a little bit of room. Think about this for a moment. What we're actually going to need is check that the door type is a specific value for red, green, blue or gold, and that the variable for the number of keys held by the player for that matching type is greater than 0. So we're going to do this with some logic. So we add a compare node first. This is like an if node, but it doesn't fit in the flow, it just does the compare when it's required. So we're comparing the door type to 2, which is the brush for the red door, and then we'll add a second compare, which is going to be comparing whether the global variable that represents the number of red keys held is greater than 0. So if both of these two things are true, so the door type is 2 and we have more than one red key, then it's valid to open this door. So that's the logic for each door type. You check the type and the key, and if they're both true, and then the output of the AND node will be true also, will be positively 1, and therefore that door can be opened. So we'll duplicate this up for that small section up for each of the door types and key types. So we're going to end up with 4 comparisons, 4 sets of comparison pairs effectively, each comparing the door type and the key type required, and then checking that both of those states are true, and the output of each of those 4 AND nodes will be true if the player is trying to open a door of that type and has the right key. So that's the first part of the check, and then what we want to check then is if any of those ANDs are true. So if you have the red key and you're opening a red door, or you have the green key and you're opening the green door, etc. So we do that in 2 steps. First of all, we check the first 2, and the output of that OR will be true if either of those is true. So that means you do have the right key to open the right door for that particular pairing. And then we add an additional third OR, which basically checks to see if either of those 2 are true. So the output of that final OR will only be true if any one of the 4 comparisons results to true. and that will basically mean you have the right key to open that door. So now finally we get to do an if. So the if is going to be in the flow in place of the door open. So we need to just disconnect that and move this door open sequence over there, and then we put the flow in there, and only if the output of that complicated check is true, i.e. we have the right key to open this door, do we actually go ahead and open the door. So we just plug that back in there to the true flow, which means the door will be replaced with the empty space, allowing the player to go through. So it looks a little bit scary at first, but if you take a moment just to review that and think about what's happening, it's fairly obvious. It should be fairly clear. So we just need to add in one more flow here for if the states aren't true. That is, you're trying to open a door that you don't have a key for, and then we'll output the variable did open as 0 in that case, so that we know that the door couldn't be opened, and that will prevent the room setting the variable. So just check those values, that all should be good. So if we go and preview this now, we should be able to go and see if we can open the red door. Now we're getting some errors in our console output here, so let's see what that says. Subgraph did not output a variable. So let's go back to our room and see where the mistake was. Made some sort of error in that flow. So let's check all of the outputs to make sure that it always outputs a value no matter how it flows through. It looks like it'll flow into this part. Yes, it definitely outputs a 1 if it did open the door, or a 0 if it couldn't. So why is it reporting an error? There's an output there if it's not even a door. So in all cases it should output something. So what are we missing? This is where we need to look through the flow carefully and try and understand what's going on. I can see it. So what I haven't done is connected up this door type to these final two comparisons here. And that will mean that the comparison will fail because it needs an input on that port. So it will fail and exit the flow and exit without putting a value in. So that should fix that. So now you can't open any of the doors because we haven't got any keys. We haven't got a red key, a gold key or a blue key, so they will not open, and it will report that we couldn't do it. Now if everything works according to plan, we should be able to go and collect the key. We should be able to see that we've got one red key now, yet one red key in our global variables, and if we go back to the room we should be able to open the red door because we have the red key. We can't open any of the other doors because we don't have those keys. So that worked exactly as planned. So that's the full logic for opening, unlocking doors and collecting keys working. But we have no way of seeing which keys we've got as a player. I can see them in the preview, but that's no good to the player. So to support this, we're going to add some instruments finally to the screen. I'll create a string as a label. So the first instrument will be just a simple text instrument, which will be the keys label. We'll set the text and choose the right text for it, and then place that to the right in the space that I've left over, but beside the main game window. And then what we're going to need to do is add 4 instruments below that, one for each key color, and we'll choose the new tile type instrument, which will be a single tile. So we just reduce the size down to a 1x1 tile and move it into place, and then we create one of these for each of the key colors, green, blue and gold. Set each one to a tile type. And in fact, what I think we'll do while we're placing these, just to make sure that everything's working, is we'll actually choose the key tile so we can see it, move it into place, and we'll do the same for the red key, set that to there, and then we set the color. So we're going to set the color for the red key to red, obviously, and this means we can see what each one looks like and make sure we've got the colours and everything right before turning them off. So if we repeat this for the last two, the blue and the gold key, then we have four simple instruments that just turn on or off depending on whether we have that particular key or not. It's always going to be type 10, and we just change the colour to blue. And then finally for the last one, just move. We need to move that because they're over the top of each other. That's why I can't see the other. So if we move the blue one over there, we've got this last instrument which we'll use for the gold key indicator. Set it to a tile, set it to 10, and to the gold colour. Resize and move that into place. So those are our four indicators which we can turn on and off very easily. We'll switch them now back to all blank because you default with no keys, so you don't need to see them. We know that they're okay, and we just change the value from 9 to 10 to turn the key on. So that's what we'll do, and we'll do that in the object logic, where we're already storing in the global variables that we have collected a key, as you remember, and all we need to do now is just set the appropriate instrument to 10, which will turn that key on and show that we have a key of that type. So we'll do that for each one. Set each one to 10, which is the tile number for the key tile. Now you see why we did the tile for the key as well. And then finally the gold one. So now this should mean that as soon as we collect a key, not only does it update the global variable so that internally the logic can allow you to open the door, but it will update the display so that the player can see which keys they've collected. So to test this, let's add a couple more alcoves to our second test room. We'll do them in the northwest and the southwest so that we have enough places to put a couple more keys. And then in our room we need to make sure that we put them at the right marker. So if we just take a note, 2 and 3, so we're going to put the green key and the blue key into those new alcoves. Let me just have another look to see which indices we want. 1, 2 and 3. So if I set that one to 1 and the blue key to 3, we should have those 3 keys in the room now. So if we play and go in there, we've got those 3 keys, and as soon as we collect one, it shows up in the instrument that we've collected that key, and the logic also registers that we've got that key. So we should be able to go back to the other room and open any of red, green or blue doors. So red door, blue door's now openable, which it wasn't before, but we still don't have a gold key, so we can't get through that door. So that's all working. So the last piece I want to add for this this part of the tutorial is a little bit of feedback for when you try to open a door for which you don't have a key. So we'll do that by adding some more instruments or another instrument and some text, and provide some useful feedback for the player. So we're going to provide feedback to the user by creating a message instrument. It's going to be used generically for any messages, so we'll make it a text, set the value to -1, which means it'll start off as empty, and spread it out across the bottom of the play area, so we've got plenty of room for long messages. I'll add a single message now, a single text string, door locked, which will display when you try to open a door that you don't have a key for. Now if you remember, where the logic checks to see whether you have a key is in the subgraph in the room logic that does that complex and an OR dance to check to see whether you have the right key for the right door. At the moment, if you don't, this test will come false and it will just silently exit with a 0 on the exit. What we want to do now is add or set the message of the message instrument to the new text string that we just created, which was 1. So the message instrument, and we'll set it to 1. So now if we try to unlock a door, or we try to open a door that we don't have a key for, we should be told that the door is locked. Now the problem is that that message will stay there permanently until it's replaced by another message now, which isn't ideal. So what we're going to do is, in the global logic, and we want it to happen all the time, we're going to add some code that will, after a period of time, remove any message that's in the display. So it's just a temporary message. So we'll add a variable to use as our timer. That's the variable that needs to be set externally when you change the message. First of all, we're going to check to see if it's greater than 0, which means a message has been sent and someone has started the timer running, or some other piece of code has started the timer running. So if it's greater than 0, then we'll reduce it by 1 each frame. So increment by -1 the message timer, and if it reaches 0, then we'll set the message to the message value, the message instrument value, to -1, which will clear the message and set it to an empty message. So that should do that. If we just set the message to -1. So that should do that. So now all we need to do is make sure we set that message timer when we set the instrument. So we'll add a set global variable here, and we'll set the message timer global variable to 50, which is about a second, at 50 frames a second if the game's running at 50 frames per second. And we'll just duplicate that for each one of these flows. And again. So that should then make sure that after a second or so, the message that's been sent will disappear. Okay, so if we try that, let's see if that works. So we get our door locked message. It doesn't seem to be disappearing. That's much more than a second. So something's not quite right. So let's go and have a look and see what we've done wrong. It's fairly simple. If it's greater than 0, decrement it. If it's then equal to 0, then clear the message. It shouldn't be necessary to check for less than or equal, because we're always going to catch it when it hits the 0, so we're going down by 1, but we'll try that and see if that makes a difference. It's worth trying these things. I don't expect it to have any effect. No, that's definitely not working. So something's wrong here. Yes, I've put the variables in the wrong place. So those are the instrument setters for the key collection. What we actually want is the instrument setters for the message, which was back in the room subgraph. Bit of a silly mistake. So if we just add one in here, set global variable, and we'll set the message timer to 50 here. That should solve the problem. So we set that to 50 again. Now this will obviously set it when it sets the message, it'll set the timer going, and the global logic that should then take over after a second or so and clear the message in each case. So let's just check that it works when we've actually got a key. It shouldn't display the message, and it shouldn't do anything to change that. So if we get the red key and go and open the red door, we don't get a message, we get the door open. So that's all working, and we've got good feedback now. So that's where I think we'll leave the logic, the functionality of the game at this particular tutorial. I just want to finish up by putting together a few interesting rooms on the map, just so we can test all of the different bits and pieces that we put together over the last 2 tutorials. So I've sped this up to save some time. It's already quite a long second part, but basically what I'm doing is just setting up some interesting bits and pieces for the game. So an end room with some rewards that you can collect at the end, and then I'm just placing multiple instances of the generic room that we've worked on over these last 2 episodes with all the different configuration variables, and then just going through and setting those configuration variables so that the room is usable. It has the right corner pieces, it has the right exits that allows you to get into the other rooms neighbouring it, and so on, and then placing some keys in different places. So I'll just let this one run through, and then at the very end we'll run through the game and make sure that it's playable. So I think that's as good a place as any to leave this part of the tutorial. A quick recap of what we've achieved this time round. We've introduced the concept of keys that can be placed in the rooms, in any room, in the alcoves that we set aside in the room graphics to accommodate those collectible items. And they can be configured per room, so different rooms can have different combinations of keys available to collect. We've enabled the player to collect those keys and stored a record internally of which keys the player has collected. We display that information on the screen, so we have some instruments now that show a rudimentary inventory, if only for keys at the moment, but it's a start. We've added some other feedback in terms of instruments and messages, so that the player gets some useful information when they try to open a door that they can't open, and we've enabled the unlocking logic to check for keys and make sure that the player can only open doors that they're equipped with the correct key to open. So that gives us all the building blocks of a basic puzzle game, and you saw at the end that it kind of works. We can force the player to traverse large or multiple locations to find keys to open locations they've seen before and get access to progression in the game. So it's all the parts are in place to enable a rudimentary puzzle game. So looking forward to what we're going to be doing over the next couple of parts of this. I'll start by introducing some enemies to make it a little bit more interesting. I've got some ideas for that, and as with this tutorial, it's based loosely on the style of Attic Attack, so it'll be a similar kind of enemy and projectile system we'll be introducing that'll allow you to destroy your enemies as you come across them, and then maybe moving on to some more collectible type things, so that there's a purpose to the game. So at the moment we've just got keys which just unlock progression, but we want to unlock progression to a goal. So we'll introduce some more collectibles and things that we can give the player to find and collect to complete the game. So if you like what you're seeing, don't forget to like and subscribe for any future updates. One thing I've been thinking about doing is I can release a .tap file of the tutorial at each stage. If anyone's interested in that, drop me a comment in the comments below, and I'll make that available for people to download. It's very simple at the moment, but it will give you a bit of an idea of how it performs on an emulator or on an actual device if you're able to get it onto a device. So let me know if you want me to do that, and I'll see you next time.